So in this video, we're going to prove some of the angle relationships that we've talked about within circles so far. So the first relationship we're going to prove is the inscribed angle relationship. So if you remember, without really looking at the proof, an inscribed angle has its vertex on the circumference of the circle, and if the angle was 20 degrees, the inscribed angle, then that means the intercepted arc is double that, or 40 degrees, or 2 times 20. So that's what we're trying to show in the picture. It's given that angle BAC is x. We want to show that arc BC is 2x. So we want to prove why an inscribed angle works. So let's take a look at it. So we can start with our given. And that was that angle BAC was x. So, looking at your picture, another piece of information that you might be able to know is that angle ACO would also be x because this is an isosceles triangle. They're both a radius. So let's write that down. Angle ACO is equal to x. And our reasoning is because it's an isosceles triangle. You could also say base angles, because that's what they are. So, looking at our triangle, I have this angle as x, and this angle is x. This outside angle right here would be 2x, because it's an exterior angle. So now we can write that down. Angle BOC is going to equal 2x, and that is because it's an exterior angle. So then, since this angle is 2x, that is a central angle, so a central angle's arc are the same. So that means that arc BC is going to equal 2x, and that is because you have a central angle, and that's what we wanted to prove, so that's it. So let's look at another example. So now we're going to look at two lines that are crossing inside of a circle. So let's look at it with some numbers to remember what it was that we were talking about. So two lines that don't meet at the center. Let's say that this arc is 40 degrees and that over here is 80 degrees. If we are looking for this angle, it's arc plus arc divided by 2 equals the angle. So 40 plus 80 divided by 2 equals 60. So this angle that we were looking for would be 60 degrees. So now let's prove why that works. So let's start with our given first. And now let's look and see what we know. We know that we have an angle. That's angle C. We have arc A and B. This should be an A. And then points J, W, G, M, and K. So if this arc right here is arc B, then this angle down here would be an inscribed angle to that arc. So this angle would be B divided by 2. So let's write that down. We know that angle J, K, M would equal arc B divided by 2. So if there's another place where that's going to happen, this arc right here between G and K would go to this angle down here. So then this angle would be A divided by 2. And that is because they're inscribed angles. So angle G, M, K would be equal to arc A divided by 2. And these both have the same reason, and that is because they are inscribed angles. So now where angle C is, if you look at it outside of the picture, maybe to see it better, this was A divided by 2, and this was B divided by 2. This angle where C was would be an exterior angle, so it would be A divided by 2 plus B divided by 2. So now let's write that. So angle C is going to equal A divided by 2 plus B divided by 2. And our reason for that is because it was an exterior angle. All right, so we're really close to getting it to be what we wanted up here. The angle C would equal A plus B divided by 2. All we just have to do is rearrange. So our last step is that angle C is going to equal A plus B divided by 2. And your reasoning for that is just simplifying. And that's it. All right, so this is our last one. Now, we're trying to prove, if you remember, when the angle's on the outside, if this is what we're looking for, and say that this was 200 degrees, then the angle is going to equal the bigger arc minus the smaller arc divided by 2. So the smaller arc we could find in this picture by doing 360 minus 200. So it would be 160. So bigger arc minus smaller arc divided by 2. So that would give me 40 divided by 2. So that angle that we are looking for in this picture would be 20 degrees. So that's what we're trying to prove, why that works every single time. So let's start with our given, like always. All right, and now let's see what kind of information we have. We have an angle A, we have arc C, arc B, and then K, M, and G are all points. So let's look at this. If arc B, if you take that outside of the picture, this arc is an inscribed angle to where point G was. So this angle right here would be B divided by 2. So let's write that. So that is angle KGM, and that would be equal to B divided by 2, arc B divided by 2. And then the same thing is going to happen up here because it's the same situation. You have this circle with those tangent lines. This is now your inscribed angle, so it's half of that arc. So let's write that one out. So that would be angle KMG, and that would also be equal to arc B divided by 2. And both of those have the same reason. They're both because it's an inscribed angle. All right, so let's keep looking. So that same inscribed angle situation is going to happen, but outside. So looking at that picture, if this arc was C, then this angle down here would be that arc divided by 2. And then it'll happen up at the top too. So this is going to be C divided by 2, and this is C divided by 2. So now let's write that. Angle, we don't have another third point, so you can add something. Let's call this F. And let's call this H. So angle FMG would be equal to arc C divided by 2. And angle HGM would also be equal to C divided by 2. Arc C divided by 2. Now those have the same reasoning because they're both inscribed angles. So really, all 4 of them could be written with that same reasoning, since they're all inscribed angles. So I'm going to go to the next page just for a little bit more room. All right, so looking back at this picture, we had C divided by 2 here and here. And then on this side was B divided by 2 and B divided by 2. So now let me draw this triangle for you outside of the picture to kind of show you what's happening. So this was B divided by 2, and this was B divided by 2. This was C divided by 2, C divided by 2, and then this was angle A. So A plus B divided by 2 would have to equal C over 2 because it's an exterior angle. So those two remote interiors. So I know I can write that now. So we're at step 4. So I can say that angle A plus B over 2 is going to have to equal C over 2. Now and the reason that I was able to do that is because it's an exterior angle. So I'm really close to having it look like what I want it to prove. All I really have to do is get A by itself. So to get A by itself, you would subtract B minus 2. So angle A is going to equal C over 2 minus B over 2, which means that angle A is going to equal C minus B divided by 2. And what you did there was just simplify. Used your algebra skills. And that's it.